forget it, you don't go over flat car.
So at the end of the day, you know, you just want to get something else the best way you can out of the water. And if you've got any swell going on, that's not
The web page is Git International.
Anyway, I'll leave you to it. Very much.
So I shut the door.
That sounds good to me. There's some people in the other rooms, isn't there? Okay, so probably the first couple of slides there might be some overlap with what's been said already, but what is BIPV, Building Integrated Photovoltaic Cells? The idea is that you're using the photovoltaic cells as part of the building fabric, so that they're doing two jobs. They're generating energy on the one hand, but they're also in some cases acting as a replacement for a component of the building element, whether that's glass or a cladding material. And so obviously we can look at life cycle analysis tomorrow, but in terms of thinking of the building's impact on the environment, you've got the environmental win there because you're substituting the PV for another material, and in that sort of instance you've then got a saving because you're not going to have to manufacture the other material. And obviously if you look at an individual building, you know, the impact of the substitution might be quite small. But then if you think of a wider cultural change within the construction industry, if we start sort of making building integrated photovoltaic something that's routine and that everyone does, obviously the net impact is really big. So there's different ways that we can consider integrating PV devices into buildings, and some people call the first building applied photovoltaics, which is to say, you know, something that's just bolted on as the sort of installations that you're used to seeing. But then we can also have more integrated BIPV, where, as I say, the BIPV itself actually replaces a building element, whether that be glazing or a cladding. And then of course there's other applications where you've got standalone PV installations that integrate into the built environment of a scheme, but don't actually necessarily form part of the building itself. So it might be something like outside you see PVs mounted on the street lamps, you know, or you could look at solar canopies for parking. We'll take a look at some of that a little bit later. So in terms of thinking, where can we integrate PV into buildings? Obviously we spent a lot of time looking at rooftops in the past couple of days, and that sort of thing seems obvious as it's the most, it's the thing that we're used to seeing. But also we can look at facade integration, and obviously that's a little bit more complicated because on building facades you've usually got things like windows and other detailing, so we need to think carefully about where that's appropriate, but it's certainly something that can be done. And then also looking at glazed elements, because we're going to look at some different types of photovoltaic cell later on, where they're encapsulated in glass and perhaps transparent or semi-transparent. And that gives you creativity as well, because you're serving a dual purpose then of allowing some light to pass through, but also generating some energy. So, why BIPV? Well, it's a big market and it's one that's growing, and the people that sort of do market research on these sort of things, I reckon that it's going to be worth 2.4 billion by 2017, and it's seen as being a real growth area. The other reason is that there's new markets for this sort of technology. If you think about like the Middle East and where really high value skyscrapers and buildings are being built, you know, they're doing some quite interesting things with architecture out there. And certainly from the point of view of UK manufacturing and looking at how we can regain our competitiveness as a nation, BIPV is something where, you know, it's not just a cheap imported cell from the Far East, which is almost like a commodity item because, you know, it doesn't matter if it's one or another. It's the sort of thing where it's going to require bespoke manufacturing capacity. You know, companies like Romag up in the northeast who will encapsulate photovoltaic cells between layers of glass, you know, things that are made to measure. Obviously there's all cost associated with that, and there's an opportunity for UK companies to capitalise upon that. And so BEC have certainly picked up on this. There's UK PV solar strategy, and that's work that Stuart has been heavily involved in. And there's a lot of really nice quotes in here about BIPV. that they're saying that BIPV can push the envelope that much further. You can only saturate so many roofs with PV, but if you look at BIPV, you can start looking at facades, you can start looking at glazing, you can look at other elements and ways of getting the BIPV in there. And it's something where UK companies are really well represented in this technology, and so the UK government's understandably trying to push this because it's a way of, sort of reinforcing our own industries. And so they're saying that, the sector's quite vibrant and that they're going to produce some interesting technologies for architects. And that also, you've got falling the cost of conventional cells, but BIPV technology is also decreasing. Obviously, it's that much more expensive if it's bespoke or if it's requires sort of small run manufacturing compared to the sort of bolt-on PV that's churned out in volume. But although there's a cost differential there, the underlying technology, the photovoltaics, are falling in price, and so the cost of BIPV will fall in price alongside that. And so there's a lot of next generation technologies in the UK supply chain. There's a company that's been based here called Dysol, looking at dye-sensitised solar cells. We're going to look at some of the different companies and what they're doing in Wales. And these technologies are near to market. They're coming through and starting to break through that period of commercialisation where it's quite awkward. But these technologies offer different and varied opportunities for creating different aesthetics in the built environment. So, here's a man that we recognise. He's been here not so long ago. And there's him and others that have said, we can't, as a nation, in terms of manufacturing PV, we can't just compete with China on cost, things like overheads, labour and all the rest of it. That's not something that we can do. So it's looking for those sort of high value products, which is obviously a message that has come through. And so at the moment, we've looked at crystalline silicon and we've said that dominates the PV sector, and there's been real cost reductions there because the equipment required for the manufacture of crystalline silicon, it's almost a commodity. It's used widely, people understand the process, and there's a market for that technology. But the challenge that we've got is that some of these newer technologies, thin film, dye-sensitised solar cells, they're new, and the technology and the machinery and the manufacturing capacity to make them is all a little bit proprietary at the moment. It's not something where you can just go and buy one off the shelf. So, although crystalline silicon is seen to be the technology that's going to dominate over the next few years, certainly there's potential down the line as these other technologies reach maturity for them to start making an impact on the market. And so, we're looking at innovative products in the UK, which hopefully will give us some comparative advantage. And so, let's have a think. So looking at Wales and the sort of strengths in Wales, this is, let's see if we can get it dark, there we go. Dysol's based out of Optic, this is obviously us here. Just down the road you've got BIPV Co, which is a sort of spin-off company from Tata, which is looking at depositing thin films on thin steel. And the idea is with the sort of, we looked at the Paris case study, the Paris farm building, that sort of trapezoidal profile steel material that's used really commonly in industrial buildings. Their idea is that if they can print thin film onto stripped steel, that can be laid in the sort of grooves, if you like, or mounted onto that sort of industrial profile roofing as a sort of cheap PV. And obviously with thin film, you've got slightly less performance, you need a much bigger area to sort of make the same amount of energy. But if you can make that very cheaply, then if you look at the cost per kilowatt hour of electricity, it can compete on that sort of terms. Obviously now, Wrexham Sharp was a really big blow to the UK industry because Sharp made crystalline silicon solar panels there. They did final assembly, they bought in the cells themselves all the way from Taiwan, shipped them over to Sharp, where people assembled them on a production line, and then because the market, Sharp's market changed, originally they started selling to Europe, but as the European market became saturated with cheap imports, the sort of European market for Sharp solar cells tailed off. The market for cells to the rest of the world from Sharp was already very small, And so the bulk of the output of the Wrexham plant actually ended up servicing the Japanese market. So you're shipping the cells all the way around the world, you're putting them together, you're shipping the modules back. That stopped making sense, and that's obviously why sort of, production there stopped. And so, in terms of looking at the UK, it's thinking about, well, if that sort of model doesn't work, what does, what other things are there in the UK marketplace? Got GB Sol, who was involved in Vicky's installation. They do module manufacturing, mounting systems, hardware, sort of some specialised stuff down there. There's a company, G24i, that make dye-sensitised solar cells that we'll see a little bit more of. They've gone through a couple of different transitions, in terms of their corporate structure. But yeah, dye-sensitised is certainly their focus. And there's another company called IQE that's like a semiconductor specialist, and one of the things they've been looking at is PVs for concentrators. Bogdan talked about solar concentrators earlier, and the idea is if you can concentrate light from a wide area onto a small photovoltaic device, then obviously you've got a small expensive solar cell, but the material, whether it's a mirror or a Fresnel lens, is actually really cheap. But the problem is that because solar cell performance changes with temperature, you need a special type of solar cell that enables you to withstand the temperature of lots of light being concentrated onto
put
a
a
small
fan
area.
behind it and keep it cool.
There's a panel, or there's these
Nice.
special gallium arsenide solar cells that IQE can do there. Other companies, Pure Wafer, were looking at making PV cells from reclaimed silicon where there were defects. There's the SARE Solar project out at Swansea University specific. There's a bit of information about specific in one of the handouts. There's been research on dye-sensitised solar cells in Glyndwr University. So, there's a real diversity within Wales. And so, this is what we're going over a little bit of old ground here. But we've got these first generation cells, the crystalline silicon, which dominate the market at the moment and we're quite familiar with. We've got the second generation thin film cells, like the type of array that's outside. And then we've got this sort of third generation of cells where we can talk about dye-sensitised solar cells, sometimes called excitonic cells or Gratzel cells. And there's other technologies that are coming down the line, things like perovskites, organic solar cells, which, they're a long way off still, but they might yield some interesting results in the future. And one of the main challenges with some of these very new technologies is that although they've been proved to work, their efficiencies are a little bit low, but also their durability as well. The sort of dye-sensitised cells, they can make them so that they'll last for, I think, 6 or 7 years at the moment. But obviously if you're putting that up on your roof, there's a real challenge if you need to replace it. And so thin film technologies, they compete on the basis of they're less efficient, but hopefully they're lower cost as well. And one of the problems is convincing people to look for these technologies is that they're a substitute product. They're not the default option, they're not the thing that people, architects, specifiers will pick as a matter of course, because it's something that they're unfamiliar with. Why would you go for something slightly unusual, slightly risky, when there's another option that is much more familiar to you? So there's a challenge there in terms of sort of encouraging people and demonstrating them the benefits of these technology and why there might be a reason to switch. And potentially, in terms of cost reductions down the line, because crystalline silicon solar cells are reliant on the sort of chunk of silicons they are, whereas thin film cells are reliant on a very thin deposition of material on a substrate, the materials cost as a function of the overall cost is lower. And there's also, in terms of the production methods, we've got Sharp on the left-hand side here and G24i on the other side. And if you look at the Sharp process, that the cells are made and then they're individually assembled into the modules with an aluminium frame and all the rest of it. Now this is something that's quite labour intensive. You can use pick and place robots and other things to make it a bit more efficient, but it's still a sort of process where the silicon is made in batches, the modules are put together in batches and all the rest of it. Whereas with thin film technologies like this G24i, the promise is of reel-to-reel processes. So you've got a big spool of material here. it runs through a machine that coats it in some sort of compound, it comes off the other end. That's a gross oversimplification, but the idea is that it's more of a continual process where you can crank the stuff out in really high volume rather than sort of small scale manufacture.